What if I told you that a tiny device is the backbone of all modern technology? Would you believe it? Imagine the year 1947. Picture a laboratory buzzing with innovation and ideas, where three brilliant minds, John Bardeen, Walter Brattain, and William Shockley, were about to make history. This was Bell Laboratories, the birthplace of the transistor. These inventors were on a mission to find a more reliable, smaller, and energy-efficient alternative to the vacuum tubes used in electronic devices. Their solution, the transistor, was a game-changer. It was minuscule in comparison, used less power, and seldom failed. This tiny device would become the cornerstone of the digital age, paving the way for advancements in technology that we could have only dreamed of before. And thus, the transistor, a device no bigger than a grain of rice, was born, ready to revolutionize the world. Now, you must be wondering, how does this tiny device work its magic? Well, let's break it down. A transistor is essentially a switch, but not just any switch. It's a switch that can be turned on and off millions of times a second. Imagine 3 layers of a sandwich. The bread slices are what we call the emitter and the collector, and the filling in the middle is the base. When a small current is applied to the base, it controls the flow of a much larger current between the collector and the emitter. This is how a transistor amplifies a signal. But it's not just about amplification. Transistors can also act as switches. When current is applied to the base, the switch turns on and allows current to flow from the collector to the emitter. Take away that current, and the switch turns off. And that's how transistors, these tiny gatekeepers, control the flow of electricity in our devices. So, where exactly are these transistors hiding, you might ask? Well, the answer is, quite literally, everywhere. Transistors have a wide range of applications that touch almost every aspect of our lives. So let's delve into some of the most common ones. Let's start with something familiar. Radios. Transistors replaced the vacuum tubes and made radios portable. Imagine carrying around a big, bulky radio in your pocket. Not so cool, right? Thanks to transistors, we can jam to our favorite tunes on the go. And it's not just radios. Televisions too saw a significant change with the advent of transistors. They shrank in size and grew in clarity, all while becoming more energy efficient. Ever wondered how your handy-dandy calculator performs complex calculations in a jiffy? You guessed it, transistors. They allow calculators to perform arithmetic operations faster than you can say transistor. Now, let's talk about the big guns. Computers. Transistors have revolutionized computing by facilitating the creation of smaller, faster, and more efficient processors. They are the fundamental building blocks of the digital world, helping us to store, process, and transmit vast amounts of information in the blink of an eye. But it's not all fun and games. Transistors also have serious industrial applications. They play crucial roles in automation, helping to control machinery and process data in real time. In telecommunications, they enable the rapid transmission and reception of signals, connecting us across continents. And in manufacturing, they facilitate precise control over complex processes, ensuring quality and efficiency. Transistors have not only miniaturized and made portable the devices we use daily, but they've also revolutionized industries, transforming how we live, work, and communicate. So, next time you switch on your TV, tap on your smartphone, or tune into your favorite radio station, spare a thought for the humble transistor. These tiny components, hidden away in the heart of your devices, are the unsung heroes of the digital age. From the device you're using to watch this video to the satellite orbiting Earth, transistors are everywhere, silently powering our modern world. What does the future hold for transistors, these tiny yet powerful devices? Well, as technology continues to advance, we are likely to see transistors becoming even smaller, even more efficient. Imagine a world where transistors are so minuscule, they're practically invisible to the naked eye, yet their impact is colossal. They could drive innovations in fields as diverse as medicine, space exploration, and artificial intelligence. But let's not get ahead of ourselves. Let's summarize our journey so far. We've explored the birth of transistors, invented by the ingenious minds at Bell Labs. We've delved into the intricate workings of these devices and seen the myriad applications they have in our everyday lives. They've fueled countless inventions, and we've only scratched the surface of their potential. The humble transistor, once a groundbreaking invention, now a silent hero of the digital age, continues to shape our world in ways we can only begin to imagine.